of introduction or prelude to applied reservoir engineering course. Earlier, we have done few courses in reservoir engineering, and we have included some of the most important aspects as well as concepts that were having a lot of weightage in industry as well as in academics. So, keeping that, this course was designed by including one of the most significant areas in reservoir engineering. And we have 7 days time, and we are planning to complete this course with the help of Excel to reduce the time, and moreover, how best Excel will excel the competency of this particular discipline. There could be number of numericals that you might have encountered in this course that can be done very easily by Excel. So that is what we have discovered, and of course, industry is following at present Excel in a very competitive way. So uh, we are going to use that in this course to enhance the understanding of the concepts in reservoir engineering in a numerical as well as in a practical manner. So before that, I would like to introduce the syllabus, the content of the course. And today in this webinar, we are going to cover the content, the course content for each day, what we are going to perform with the help of Excel as well as theoretical concepts. And we will start everything from scratch. So this course will help you to understand from the beginning. It could be of any background. They can start learning from the beginning of reservoir engineering, and it's wonderful subject. Of course, one of the most important in subject in petroleum engineering, oil and gas industry. There are so many areas out there where reservoir knowledge is required. So this course could help all of you. Like if you participate in this, definitely I believe if not today, in future, definitely it has some impact on your career. And then we will start today. This is the topics what I have picked from the course. I'm going to show you few slides of that particular topics. That is life cycle of a reservoir and properties, very important properties that we are going to discuss today. It's an introduction, but briefly we are going to discuss in our course with the help of our tool, that is Excel, and then flow resumes and reserve estimations and the outcome of this particular course, and a brief introduction to all this. So let us start with our day one. So we are going to discuss about the asset life cycles, roles, and hydrocarbon reservoir description. It is the introduction part of reservoir. What is reservoir in oil and gas industry? What is source rock, cap rock, reservoir rock, and what is the life cycle of it? A reservoir, if it is considered to have a life, how much span it could be, and what are the stages which were present inside that life cycle, that we are going to discuss about that theoretical concept. Then it comes to the next important part of understanding reservoir is the properties and characteristics. So what are the properties that has to be understood in a significant way, because it is not just understanding it, these are all dynamic properties, and certain properties have more impact on reservoir performance than the other properties. So what are those properties which has more weightage towards the performance? So ultimately the goal is to exploit oil commercial. So for that, certain properties are more, they're sensitive, and most of the properties are all important. But the thing is, there could be some particular properties which has more weightage. So that properties, how it is going to help us to enhance the productivity of reservoir, that can be understood in this area. It covers theory as well as some part of numericals, and some of the properties are like porosity, permeability. Probably this might have been heard by most of the people. Today I'm going to introduce to you to porosity and permeability, and then the next step to that is the relationship between porosity and permeability, and comes with rock and fluid compressibility. So these are all the properties. Beyond that, there are some more properties are there that also we are going to cover At the same time, we are going to briefly discuss about these things like an interactive way, and definitely it will help you to understand in a very precise way. So that is the main motive of day one. Like you have to introduce, you have to enter into this area like by complete confidence. Then next comes some more important properties of rock like wettability, and the part of permeability we have three, that is effective, absolute, and relative permeability. So we are going to see the relationship between wettability and relative permeability. So what is the role of wettability for the production of oil from the reservoir? So how wettability will have influence of oil production? So that we are going to discuss. What is the role of wettability? So it is today in this generation, and a lot of research is going on in this parameter, that is wettability. And then the parameter which has a significant function on another parameter, that is relative permeability. So what is relative permeability? How these both can be observed while oil starts to get mobile inside the reservoir, as well as if it starts to get produced, how these variations will be there that can be observed in these two parameters, that is wettability and relative permeability, and relationship between capillary pressure and surface tension. So these are all like fundamental concepts of earlier science, like what is surface tension, interfacial tension, and how this has an impact on oil production, and what is the role of capillary pressure. So capillary pressure, today I'm going to introduce to you to capillary pressure also. So how capillary pressure will help you to identify the production key, so to enhance the whatever amount of oil that has to be produced, that has to be enhanced by the application of capillary pressure, and how it is related to surface tension. Then comes capillary pressure curves. So we have a separate theory to construct capillary pressures for our reservoirs, that is oil and gas reservoirs. So how these capillary pressure curves will be generated, so that we will be discussing. And phase behavior. So inside a reservoir, we are going to see two phases. One is oil as well as liquid and gas. So how, when you alter pressure and temperature, how the volume of oil, liquid as well as gas will start to get balanced. Since the volume is constricted, the balance between liquid and gas will vary. So how it is going to be varied, and where exactly gas starts to get eliminated from the liquid, so that that kind of points, like sensitive points or pressure points, that we will be discussing in this area. Then comes calculation of hydrocarbons in place with volumetric methods. It is one among the reserve estimation techniques, that is volumetric analysis. We have other techniques like material balance, production decline, and reservoir simulation. So day two, we are going to start with reservoir estimation techniques on volumetric, and we are going to use Excel to estimate the value of the amount of oil by learning the equation with theory. When it comes to day three, we are going to see the derivation part of material balance. This is the second part of reserve estimation technique. And material balance equation, there is a derivation. It is a bit bigger one, but the thing is, I'm going to give you the best way to reduce the difficulty to understand this derivation, that is material balance equation. It's very much easier to get the just you can able to see with few things you can able to estimate. Okay, this could be the equation. Overall equation can be remembered in very less time. So that we are going to discuss on day three, and then MBE deduction with Haviland-Bode method. So this is one deductions from material balance equation. What are the additional things that can be derived from MBE with this scientist that we are going to discuss? And then oil well testing theory, like radial flow theory, as well as what is wellbore damage, wellbore storage, as well as skin. They both represents damage around the well. So how these things can be estimated with the help of oil well testing, that also will be discussed in day three. And drawdown and build up curves, which represents well testing techniques and which were mostly conducted in well testing, which is part of reservoir engineering. And by the help of these shapes, which were observed in drawdown and buildup, we can interpret certain parameters like skin effect, like leakage, like there could be damage around the well. So you can able to estimate by seeing the curves which have been constructed by drawdown. There is an ideal graph will be there for drawdown and buildup that we are going to discuss it. If there is any variations are there, what could be the cause for that variations that will be observed by drawdown and buildup curves. Type curve analysis. It is an ideal graph. So we are going to use this graph to estimate permeability, storativity. So there are some kind of parameters that can be estimated by the help of type curve analysis. So this we are going to use to estimate. These are all the techniques which comes under well testing, which is a part of reservoir engineering that will help us to identify permeability, like reservoir parameters and other kind of significant areas that can be estimated by the help of these curves that we will be discussing. And pseudo steady state and unsteady state flow, these are part of flow regimes that we are going to observe. Once you start drilling a well, you're going to see that the flow, what is happening inside a reservoir, will start to deviate in a different way. So initially you can able to observe a particular flow, then after that the flow will change. So these changes, why it has been changing, what is the limit of a drainage area, how much extent the flow can be extended, where could be the well influence will be inside the reservoir, like radius of investigation and the drainage boundaries. All these things will be understood in this concept. That is pseudo steady state flow. We have like steady state flow, pseudo steady and unsteady state flow. So today I'm going to introduce to you to one among these flow regimes. Then comes PI, represents productivity index and inflow performance relationships. So these two curves, productivity index will help us to understand the production capacity of a well, and inflow performance relationship, like well testing, is this will also help you to interpret how the well started to get produced. Is there any kind of water encroachment or any kind of disturbance was there around the well, that can be understood by IPR curve. Then comes day 5, that starts with gas well testing, and in that gas well testing we are going to discuss about pressures, pressure squared, real gas pseudo pressure solutions, multi-rate testing. So these are related to, earlier we discussed about oil well testing. Right now we are going to cover gas well testing by the help of pressure squared method. So gas, the theory is different. Oil, the theory is different. So, but the equation applications, we are going to estimate the amount of either oil or gas that has to be produced. But we have to consider certain more parameters if you are estimating for gas when it is compared with oil. So in that way, we are going to see how gas well testing will help us to identify the amount of gas that can be produced by the other parameters. Then comes gas well deliverability. So this is also a well testing technique that will be helping us to understand what is the absolute open flow of a well to produce the maximum outcome of gas. So that can be understood. The deliverability should be maximum. So how it can be estimated? What could be done to know that that particular well can able to produce the best amount of gas which was present inside the reservoir? Every well has its own capacity. So what could be the best stable flow rate of that particular well for that reservoir for gas will be estimated in gas well deliverability test. And then after that, introduction to aquifer. So which is beyond reservoir, we are going to see a big water pool, that is aquifer. So definitely aquifer has a lot of influence towards reservoir pressure. So it will maintain, if the aquifer, if you could able to keep the aquifer on right location, then definitely the reservoir pressure which was around the reservoir, that will be maintained. In that way we can start producing good amount of crude oil. But if aquifer always have a chance to penetrate into the oil zone, so that has to be avoided. So this is one among the significant areas that reservoir engineers will look into it. So we have to understand the significance of this aquifer technology. Then comes aquifer estimation, the amount of water that starts to get encroached into reservoir, that will be understood by different scientific formulas. That is, first one in Everdigan, Carter, Tracy, and Fetkovich method of aquifer analysis and description. So these scientists have given the amount of water entering into reservoir, encroaching into reservoir, that has to be estimated. So they have given numerical formulas that we are going to use in Excel to estimate with the help of other parameters. Immiscible displacement. So water will displace oil. That happens in water flooding mechanism. So how much water is required to displace oil? So that has to be understood. So that can be done by fractional flow equation, Buckley and Liberty and Welch equation. So these equations will help us to understand what is that fractional amount of water that can able to displace oil from the reservoir. So you have to understand how much amount of water is required fractionally. That can be understood in this equation. That we are going to discuss the derivation part of fractional flow, as well as we're going to see a numerical part of it with the help of Excel. Description of coning represents water coning. Cusping represents gas cusping, and over under running critical rate calculations and breakthrough times. So these are very important areas to avoid the damage inside the well, so that you can able to produce good amount of oil by keeping water behind. And water has to be kept behind so that it will act as a drive. And horizontal well application. So we're going to see horizontal wells. That is another technology that is very important, so that we are going to understand the technical part of horizontal well and its applications. Then comes gas reservoirs like volumetric. So water, there are different types of reservoirs are like gas reservoirs, volumetric, water drive, compaction drive. So these are all different kinds of drive mechanisms that will help oil to produce inside the production well. So that can be understood. We have to go through the theory part of drive mechanisms, as well as how best these drive mechanisms will help us to produce crude oil into production well without application of any energy from the industry side. These drive mechanisms were kept inside it was there naturally, which was present inside the subsurface, that will help us to produce crude oil by itself. Only the thing is, a reservoir engineer has to manage these drive mechanisms by maintaining the flow rate as well as pressures. In that way, we can able to use the drive mechanisms which were present naturally inside the reservoir, that will push oil towards your production. You can exploit it without investing anything. So this is how, this is the reason it is very important. Drive mechanisms are for a reservoir engineer to understand drive mechanisms is one among the most important areas to reduce the investment costs. Then introduction to naturally fractured reservoirs and critical reservoirs for fluid reservoirs. And finally, we are going to end with reservoir simulation. So why we have to simulate? And this is the last part of reserve estimations. So there are 4 parts of it. One is volumetric, material balance, production decline, and the final one is reservoir simulation. And today in this generation, a lot of softwares have been developed for this technology, that is reservoir. But before entering into any kind of softwares, you need to understand the conceptual part of simulation. So why we have to simulate, and we are going to use certain tools to simulate. How best we can able to simulate it. So the tool what we are going to use is mathematics. So how I'm going to introduce to you to very few techniques in mathematics that will help us to simulate nearby unknown or any new values, or with the help of known values, we are going to estimate unknown values. So there are certain techniques are there that we are going to introduce in our reservoir engineering course at the end of the 7th day. So from this, we are going to get very good information about reservoir engineering, and we could able to cover aquifer, reservoir estimations, flow regimes, dry mechanisms, oil well testing, gas well testing. So we have a very good content on this particular course, and this has very good impact for getting very good knowledge in reservoir engineering. And I believe you, whoever coming to this course, please do not miss anything. We can able to interact so that it will be even more interesting. So today I'm going to introduce some among the few slides what we are going to discuss in our reservoir engineering course. So some people are sending chat messages. I'm just wondering what could be. Okay, then I will continue now. I will reply to that at the end of this session. So let me continue with the presentation. So we will start with the life cycle of reservoir. Very simple. It will be understood very easily. Let us think that reservoir is having a life. So before getting into reservoir, I'm going to introduce what is a reservoir. Reservoir is a rock. It is a rock where crude oil has been deposited. And this deposition happens with migration. And before oil gets migrated, it will be generated in a source rock. So source rock is a rock where oil will start to get generated over there. That is the birthplace of crude oil. From that, migration will take place. Why? Because source rock doesn't have a property known to be porosity. So, sorry, it doesn't have a property known to be permeability. So when there is no permeability, there won't be any transformation. Porosity is the place where crude oil will be deposited. So porosity is an empty spaces inside the rock. So that will be inside the source rock where crude oil will be generated, but it will not migrate from one place to another place. It has to be expelled from the source rock towards a place where some other kind of fluid will drive that oil towards another rock, that is reservoir rock. So I'm going to discuss about that briefly in the course. Just I'm giving you a brief introduction to that. Once the oil comes towards reservoir rock, it will be trapped by a trap rock or else a cap rock where it is not having permeability. So a non-permeable cap rock will trap oil which was blocked inside a reservoir rock. So reservoir rock will carry crude oil as well as some part of gas, and that will be in the form of inverse of a convex shape. So this is how a reservoir rock will be formed after migration. Then it could take some amount of time to get matured inside a source rock. Then after that, it will be transformed to reservoir rock. So once it is trapped there, then the job of oil and gas industry people to start drilling into a reservoir rock, and they have to exploit it. So this is the next process of it. So once we discover that the oil was present inside a reservoir rock, we have to estimate the life of a reservoir. Why? Because we starts to exploit the crude oil, so that will be having a span. So let us see how the process of reservoir will be happening with respect to production rate. So production on y-axis and the time on x-axis. So production, I'm comparing the lifespan of reservoir rock with the representation of production, so that at every span we have 5 stages of life of reservoir. So at every stage it will allow us to get some amount of crude oil. So how that crude oil can be exploited at each stage, let us see. First stage is exploration. So it may take from 3 to 5 years, and the production part you can able to see a little bit what we have observed over here. So the time it takes for like where the crude oil have been deposited inside a reservoir rock, we have a lot of technologies. It's a big industry where we are going to use geological techniques, geophysical techniques, well logging, seismics, and airborne techniques. So every technique will be helping us to identify where the crude oil have been deposited at what location. It could be either on land or at offshore, so marine land. So by ships, by jets, airplanes, everywhere they're going to use different techniques to identify where the crude oil have been deposited. In place of crude oil, even the gas is present. That also is a reservoir rock, gas reservoir rock. So that also is a commercial product for oil and gas industry. So both sides we are going to explore and we're going to discuss. So this part will take around 3 to 5 years. Then comes delineation and appraisal phase. So what is delineation? Delineation is the phase once after exploring crude oil inside a particular location. We are going to dimensionate it with XYZ axis. So three-dimensionally, we are going to decide. We are going to define the area of that particular crude oil reservoir, how much extent it has been expanded. So that is delineation. When it comes to appraisal, so this is the part explorationists have done their job. But to go to the next step, they have to appraise that. Here the problem comes how much we are going to invest so that the oil, what we are going to get it, that has to provide profit beyond investment. So in this way, there are a number of projects that have been delayed or else it has been cancelled. Why? Because it depends on the amount of oil what is present inside the reservoir. A little bit amount of oil, if it is there inside reservoir, maybe company may not pay that much interest at present. So because of that, appraisal phase is very important, where reserve estimation techniques will come. Before getting into the reservoir, you will start estimating the amount of oil which was present inside the reservoir. Commercial amount means it has to be exploited with present technology. We do have technology, at the same time limitation. So based on this, how much extent we can able to extract crude oil from the reservoir, that has to be estimated, and it will be provided as a report in appraisal phase, so that the industry will start progressing for the further stages. So next, during this appraisal stage, they're going to do some testing techniques. In that way, you will start producing some amount of crude oil. So that is the phase which will carry from 2 to 5 years. Then comes, once company approves to carry on the project, then the next step is development phase. So you will start drilling a well, you will start doing well testing techniques, everything before start extracting crude oil completely. We are going to produce some amount of oil for testing the well. That itself will take you around 5 to 7 years. So this is the phase where we will be naming it as development phase. In this phase, well testing will play a significant role. So where we are going to test a well to understand the best capacity to produce crude oil from the reservoir, that can be understood in this development phase, where productivity index, IPR, that what we have discussed in day 4. So there that part will come in this phase. Then comes the real one, that is the production phase, which is a plateau that will be carried on from 10 to 15 years. So you developed the well and you started to produce the well. How much extent it can be produced? By the application of dry mechanisms. Initially, oil will start to get produced by only dry mechanism. So this is the part which starts initially, and that has to be understood by a reservoir engineer in a very competitive and significant way. Why? Because if you could understand dry mechanisms well, then the management of these dry mechanisms could able to enhance you to produce the best amount of oil which was present inside the reservoir. It could be 60% or 70% that can be produced by dry mechanisms. So the remaining part, that has to be done by our technologies. So once dry mechanisms phase have been declined, that means that up to production phase, the investment on the industry was very low. Then after that, you start to inject water to produce whatever oil which was present next to dry mechanism, which was left out next to dry mechanism, that has to be produced by water flooding. So in that way, the process of declination will start. So this is the phase where a lot of challenges that has to be addressed, and where here we are going to see two different areas. One is water flooding, another one is um, enhanced oil recovery. So these two phases where you can see different technologies will be applied to enhance the production. And this decline phase has to be delayed as much as possible. Why? Because how much you delay, that much amount of crude oil that can be produced. So the time is a driving factor over here. So that according to reserve estimations, if it could be producing around 20 years, so how best we can do to enhance it to 25 years. So during that 5 years, we can produce additional amount of oil. So this is the phase which is very significant, where enhanced oil recovery has an important role to ensure for the extension of the life of a reservoir at a declination phase. Then after that, if you believe that the oil what was present inside the reservoir have been extracted to the best of the technologies what we have, then we have to abandon the well. If not, if you think that we need certain maintenance operations, then we have to go for decommissioning. After that, we can abandon it. So this is the last phase. It is not just to leave the well as it is, but before that, whatever activities that has to be done in decommissioning phase as well as abandonment, that will be done in, and it will take around 2 to 5 years of the lifespan. So this is the overall life of a reservoir, and the role of reservoir engineering starts with the end of exploration to the start of decommissioning. So where a reservoir engineering has to pay attention, and he has to give good suggestions so that the life of a reservoir can be extended. Then comes, we are going to discuss among, we have different properties that we are going to discuss in our course. But here I'm going to give you a very brief introduction to few properties. That is, one is porosity and another one is permeability. What is porosity? So these are the pore spaces which were present inside a rock. Rock carries grains as well as empty spaces. So grains means part of minerals which have been attached by the help of clay. So that part, there is no empty space, but the remaining part of grains will be empty. So where the crude oil will be deposited in that empty spaces. So we are going to measure that empty space, and that measurement we will be naming it as porosity. So how it is going to be measured? That is pore space volume by bulk volume. Bulk volume includes overall volume of the rock. Pore space volume is the space which was empty, that was present inside the rock, that is considered to be pore volume. So pore volume by bulk volume will give you the value of porosity. And it is a fraction. The answer lies in between 0 and 1. And mostly it will be less than 0.47. That means 47%. Why? Because the best porous material in this globe we consider to have as sponge, that is having 47%. So the reservoir rocks for oil and gas industry will not pass beyond 40%. So it could be around 35, 30, 25, so something like that. So it will be in the range of 15 to 35. So that could be the best area of porosity. Then comes permeability. So the same here, the permeability means these pore spaces which were present inside the reservoir should have some kind of passage. They should be connected to each other. If you could see these arrow marks, you can see that there is a passage that can be observed. So you can see it started from here and it can be moved inside the reservoir rock, where it has a place to move away from one place to another place. So it can migrate from one place to another. So this passage is understood to be permeability. So if there is no passage, if it is blocked, then oil cannot move from one location to another location. So permeability represents the interconnected pore spaces inside the reservoir rock is understood to be permeability. So interconnection is very much important. So this is what it lacks in source rock. So where it cannot bypass from one location to another location. So this is very important property that drives oil from one location to another location. So how it is going to be estimated? This was given by Darcy's law, where Q represents flow rate of oil that is equal to minus Ka by mu dou P by dou L. So K represents permeability. That is the one which we are discussing. And A represents area of this reservoir rock. Mu represents viscosity of this oil which was present inside the rock. dP represents pressure difference. Since oil will start to move from high pressure to low pressure, so the difference of that pressure is dP and dL. It is like in the direction of x-axis or length. So it will start to move from one location to another location. That means the pressure over here should be high and the pressure over here must be low. With that pressure difference, it will start to move. And there is a minus symbol which was present over here. So why it was given minus symbol means to make overall flow rate to become positive. I'm going to give you a simple numerical example and you can understand why that minus symbol came. Let us see that the pressure starts at P1, that is 2000 PSA, and P2. So with the difference of 2000 PSA and 1970, so we have 30 PSA difference between P1 and P2. Oil will start to flow from one location to another. So this is P1 and this is P2. So dP means P2 minus P1, that is minus 30. Then let us see that the length, it started at 12 feet and it is moving until it reaches 18 feet. Okay, this is L1. It started at here and it is moving to 18 feet. So from it started at 12 feet and it ended at 18 feet. If you could keep these values in this dou P by dou L, then the value of dou P is P2 minus P1, that is 1970 minus 2000 by 18. That is when you are taking P2, then you have to take L2. So L2 is 18 and L1 is 12. So the overall outcome is minus 30 by 6 and minus 1. So the outcome is coming in negative. Once you keep this value over here, it will become overall positive. To make the flow rate to become positive, we are going to use negative symbol. So that is how we are going to estimate permeability. And then let us start about capillary pressure. So this is also a very important property of a reservoir rock. So let us see that this is a blue color rectangle was there, which is a pore space. Let us try to imagine it's a pore space inside a reservoir. So oil will start to enter by displacing water. So let us see that the oil part is coming and it is pushing water away from the reservoir rock. So what does capillary pressure means? We need to understand initially every reservoir rock is filled by water. So that means reservoir rock has attraction much towards water than oil. So oil is a foreign substance for a reservoir rock which was filled with water. So water is the one which we will be talking it as wetting phase. Why? Because initially it was wetted with water. Then after that, a non-wetting phase have intruded by displacing wetting phase, that is oil. So capillary pressure is nothing but the pressure difference between non-wetting phase pressure and wetting phase pressure. So here the non-wetting phase pressure is oil, which was represented in green color, and the wetting phase is water, which was represented in blue color. So pressure of oil minus pressure of water is capillary pressure. So this is how capillary pressure can be defined. So this is one formula. Another formula to estimate capillary pressure, if you have certain parameters like surface tension, the tension between rock and any fluid which was present above it, and theta is the contact angle, that is the angle which was made by the menisci, which is in between oil and water, and RC represents a radius of capillary tube. So I'm going to show you in a diagrammatical way, so you will be understanding. If you have these values, then you can able to estimate PC as 2 sigma cos theta by RC. So let us see what is theta, what is RC. So this is a tangent which was made on the menisci towards reservoir surface, and this angle we name it as contact angle. So this is what it is, cos theta is all about. So theta is the angle which was made by the menisci in between oil and water towards the reservoir surface. So that is theta. And what is RC? C represents capillary tube and R represents radius. So how it can be discussed as this? See this, if this whole rectangle is a cylinder, like if it looks like a cylinder, then the radius of this cylinder is RC. Simple. So this is RC and that is theta, and sigma is surface tension, which was measured with respect to dynes per centimeter square, that can be estimated in between a rock as well as fluid. So that has to be estimated in laboratory. So if you have the values of surface tension, contact angle, and capillary radius, then we can estimate the value of capillary pressure. So we have two formulas. If you have simply the pressure of oil and pressure of water, the difference will give you capillary pressure. Or else if you have these values like capillary radius, contact angle, and surface tension, then we can able to estimate the value of capillary pressure. We are going to see one numerical by the help of Excel that will help you to understand even more better. Then let us come to one among the most important topic in our and the last one of our session, and this is the part of flow regime. One among the flow regimes that I'm going to discuss in this slide, that is unsteady state flow. So before I get into, we have three types of flow regimes. One is steady state, pseudo steady, and unsteady state flow. So I'm going to give you the meaning, the definition of unsteady state flow in today's session. So let us try to understand what is unsteady state flow. And before that, you need to understand this is very important very important flow regime that happens at the start of production. So before you start producing a well, let us try to think that this is a reservoir. You can see a black color rock which is having a reservoir pressure of 2000 psi. It is at some target depth. Let us consider this black color rock as a reservoir where crude oil have been deposited. So how this can be extracted? Before that, we need to start drilling a well. So let us start. We have drilled a well, and after drilling a well, you need to produce it. So we have perforated the well, and you need to start producing. So once you start perforating the well, oil will start to come into these perforations and it will start producing into the well. So while this process is happening, pressure drop will start to expand into the reservoir. Initially, the pressure around the well is also 2000 psi. So you can see everywhere, wherever you measure the pressure, that is 2000 psi. Normally, it was present everywhere, 2000 psi. It is like everywhere it is there. So once oil start to produce into the well, then it will start to create a pressure wave around the well bore, and the pressure will start to get reduced. If pressure is not reducing, then the flow of oil will not happen. If both pressures are same near to well bore and reservoir, then there won't be any flow. So after like perforating a well, then the pressure difference will be generated. Then this green color circle represents a pressure wave around the well where it was perforated. And here the pressure was observed to reduce. It is not 2000 psi, it has reduced to 1900 psi. So right now, the pressure outside of the green color is 2000 and inside it is 1900. So there is a pressure difference of 100 psi. Because of that, oil will start to produce from the reservoir. There should be some pressure difference to produce oil from the reservoir. So that has to happen near to it. So the pressure reduction should make flow should have pressure reduction should make that flow to happen from reservoir drainage boundary to the well bore. So that is how the oil will start to enter into the well bore by pressure difference. So this might have taken 1 hour time, or else any time it could take to reduce the pressure from 2000 to 1900 psi. So that is that green color pressure wave. Then after some more time, the pressure wave will expand. From green, it became to red color. So here, the pressure difference is progressing into the reservoir. So inside red color pressure wave, you can see the pressure is 1900 psi. But still the earlier wave, which have been expanded, and it created a new wave. So that new wave will have a pressure of 1800. So earlier it is 1900, right now it is 1800. So you can see the pressure difference right now, 2000 psi. Inside red it is 1900, inside green it is 1800. So earlier it is 1900, right now it has reduced to 1800. So the pressure reduction is increasing when time is progressing. Why? Because the pressure reduction is progressing into the reservoir. Then after this, you have to go for another wave. So this is the third wave where this 1900, which was present inside the red, have progressed further, and 1900 have become 1800, where 1800 have become 1700, and the new wave is considered to be 1900. So once these waves are moving forward, the earlier waves pressures are being getting reduced. Because of that, you can see the pressure difference started to encounter from 2000 psi to 1700 psi. So time increases and pressure reduction is also increasing, so that the amount of oil which starts to flow into the well also will start to rise up. So in that way, if still more time goes up, then it will be progressing further. The new one will be having 1900 psi, and the earlier one, which will be having 1800, and the before that one will be having 1700, and the first one near to the wellbore is having 1600. So right now, from the drainage boundary to wellbore, the pressure difference is 2000 psi to 1600 psi. So we have 400 psi difference is there to make oil to move from reservoir drainage boundary to the wellbore. So this is a very good amount of pressure reduction that will help oil to move from drainage boundary to the wellbore. So let us go for the final one, which is a new wave, and it could be the end of the drainage area of the reservoir. Beyond that, it may not progress. So this is the end of drainage area. So here, the new wave which have been generated will be 1900, and the yellow one which is next to that have been reduced to 1800, and before that one have reduced it to 1700, and before that red one have reduced to 1600, and the green one which is near to elbow have reduced to 1500. Right now the pressure difference is 500 psi. Oil starts to move even more stable and faster and in a constant way towards your production well. Why? Because the pressure difference is more. Earlier when we started perforations, we have only 100 psi difference, and right now at the end of some time, at the time we will be naming that as transient time. At the end of transient time, the pressure reduction in between drainage boundary and wellbore is 500 psi. So this is a very good amount of pressure drop or else drawdown that will help oil to get produced in a constant way. So this is unsteady state. This happens initially once after drilling a well. Immediately it will start to happen. That is unsteady state flow. Then after that, other flow mechanisms are there that we will be discussing in our course. So this is how the initial part of flow regime that we will be seeing. So the first flow regime that will be encountered immediately after drilling the well is unsteady state flow. So that will take some time for the pressure disturbance to start moving from the wellbore to the final boundary. So this is the technical part that we have been discussed. And after that, the outcomes of the course, whatever at the end of the course, you can able to understand the physical and critical properties of reservoir rocks as well as fluids, how PVT relationships will be adjusted, how the liquid volume and gas will be understood with the help of pressure and temperature, and volume variations will be understood. We are going to calculate hydrocarbon initially in place using several methods by the help of Excel. We can able to understand some among very important aspects of Excel that will help us to understand reservoir even more better. So this technique that whatever techniques we are going to use in Excel will help you to analyze the performance that itself will give us some inheritance. So that can be understood. Determine the parameters that impact well reservoir performance over time. So there are some sensitive parameters are there among other parameters, which will have very good driving mechanism towards the production well. So that may have very good impact on the reservoir. That also will be understood. Analyze well tests using standard well testing principles and techniques. We are going to introduce to oil well testing, gas well testing, and how these testing, which were in development phase, that will help us to understand what are the damages around the well and how to estimate permeability, skin, wellbore damage. That also will be understood. And characterize aquifers. Aquifers is a very big topic, but still we will try to understand with the help of Excel. It will reduce lot of efforts to understand, so that we will be discussing in aquifers. And determine reservoir dry mechanisms for both oil and gas reservoirs. So dry mechanisms play a very major role because that is the initial driving that is the energy that we need to maintain in such a way that without investing you will start exploiting crude oil. So understanding dry mechanisms is very good, a very important part of a reservoir engineer, that we are going to see how to identify every drive mechanism and what best can be done and which drive mechanism will have good impact on production. Apply oil and gas field development planning principles. So these, if you could understand these properties and all these things, then the planning could become even more sophisticated and precise. We can able to understand the performance, we can estimate well, and we can go for appraisal so that the chances of getting a positive outcome could be even more better. So more understanding of reservoir will give you more amount of confidence to start defending in such a way that we can get the right proposal. And forecast production decline. Always the declination phase has to be, it is not just about forecasting, but it has to be delayed. How best can be done to delay? What could be the possibilities that a reservoir engineer can do to delay the, like declination phase for longer period? So that is how we can able to understand, and these could be the outcomes of the course what we are planning in coming days. Thank you for participating in this webinar. I hope